Good morning everyone. Welcome back to grade 5 mathematics class. How are you all doing today? So we have been learning about the highest common factor or HCF of a few given numbers, right? So today we'll see some word problems involving finding HCF. So let's see the first question. Before that, let's talk about some keywords. So we have already learned about the keywords which we can use to identify a given word problem is whether it's addition, subtraction, multiplication or division, right? So similar to that, for word problems involving HCF, there are some keywords that we can use as a help. So these are some keywords: greatest possible or largest or maximum or cut equally or divide equally. These are some keywords, a very few keywords that we can take as a clue to identify a given word problem to find the HCF. So let's move on to the first question now. Find the greatest possible length of a wire which can be used to measure exactly two wires of length 18 meter and 24 meter respectively. So what you are asked to find? In the question it is said that you have two wires, one of length 18 meter and the other one of length 24 meter, right? What you are asked to find? You are asked to find the measure of a wire which can be used to measure these two wires exactly. Means we are going to measure using a smaller wire and use it to measure these two wires. So practically you are going to divide these two lengths, right? And how exactly you are going to measure it exactly means without leaving any remainder, right? So let's see how we can do that. In the question we can identify that you are asked to find out the greatest possible length of a wire or the greatest possible number which can divide these two numbers 18 and 24 equally or completely without any remainder. So what is that? You are asked to find the HCF of these two numbers. So let's see how we can find the HCF. We have already learned two methods to find the HCF. One is the prime factorization method and the other one is short division method. So let's find the required length or the HCF of 18 and 24 by prime factorization method now. So how do we do the prime factorization method? Let's factorize these numbers in terms of its prime factors alone. So 18 prime factorized give you 2 into 3 into 3 and 24 prime factorized give you 2 into 2 into 2 into 3. Now how do we find the HCF now? We have to find out the prime factors which are common to both these numbers. So this 2 is common to both these numbers and this 3 is, there is one 3 which is common to these two numbers. So what do you do next? You have to multiply. You have to take one from each of these common groups and you have to multiply those two numbers and that will give you the HCF. So from this group of 2 you are taking 1 2 and from this common group of 3 you are taking 1 3. So what is 2 into 3? 2 into 3 is 6. So that is the HCF of 18 and 24 by using prime factorization method. Now, so that gives you the greatest possible wire length of 6 meter, which is the HCF of these two numbers. Let's see the other method as well. Using the short division method, how do you find the HCF? First, you have to write the given numbers in a grid. So 18 and 24. Now, what is the next step? You have to find out the smallest possible prime factor which is common to both these numbers, which can divide both these numbers together. So what about 2? Let's try with 2. 2 is the smallest even prime number. So can 2 divide both these numbers? Yes, 2 can divide. So let's take 2 now. Then what do? You have to divide each of these numbers with this prime factor. So 18 divided by 2 gives you what? 9. Now 24 divided by 2 gives you 12. Now again we have to divide these two quotients. Now can you use 2 to divide both these numbers? You can divide 12 but you cannot divide 9, right? So 9 is not a multiple of 2. So what about 3? 3 can divide both 9 and 12. Why? Because 9 and 12 are multiples of 3. So we can use 3 here. 3 is a common factor, common prime factor for both these numbers. Now let's divide each of these quotients with 3. 9 divided by 3 gives you 3. Now 12 divided by 3 gives you 4. Now is there any number which can divide both these numbers together? Any other prime numbers? No. So let's stop the division right there. So we stop the division right there, and you have to take the common prime factors and find the product of those prime factors. So you have 2 and 3. You have to find a 2 into 3. So HCF is equal to 2 into 3, that is equal to 6. The same as the product or the HCF that we got using the prime factorization method. So it doesn't matter which method you are using, the highest common factor or HCF of 2 or more numbers are going to be the same. So the greatest possible length of the wire will be equal to 6 meter. So since we got the answer, let's explain the question once again. So this is the 18 meter wire and this is the 24 meter wire, and we got the HCF as 6 meter, right? So I've used 3 different colors so that will be more clear to you. So we got the HCF as 6 meter, which is the greatest possible length of a smaller wire that can be used to measure these two wires. See, I'm taking this 6 meter and there is one 6 meter here, one 6 meter here and one more 6 meter here. So this 6 meter wire can measure this 18 meter wire in 3 equal divisions and completely also. There is no remainder or no length of wire left. And the same 6 meter wire can be used to measure the 24 meter wire. See, one 6 meter here, 6 meter, 6 meter, 6 meter. So it's 6, 12, 18 and 24 meter. There is no length of wire left. The same 6 meter wire can be used to measure the 24 meter wire also without leaving any remainder. So that is the HCF, for the greatest possible length of the wire that we found out. So I hope this is clear to you. Let's move on to the next question now. Find the greatest number that divides 149 and 101, leaving 5 as remainder. So what is the question? Find the greatest number that divides these two numbers. Which are the numbers? It is 149 and 109. You are asked to find out the greatest number that divides both these numbers. But in that case, you are getting a 5 as remainder. So we know what is HCF. HCF is the greatest possible number that divides the given numbers completely without any remainder. So if you are asked to find out the greatest number with a remainder of 5, don't you think if we are dividing numbers which are 5 less than the given numbers, that greatest number will be dividing those two numbers completely without any remainder? I mean, we have 149 and when you are dividing with the greatest number, you are getting 5 as the remainder. So you are subtracting 5 from this. So that will give you 144, right? So when you use the same number to divide 144, it should be dividing it completely without any remainder. Why? Because we have already subtracted 5 from the given number, right? So similarly, from 101 also, we are subtracting 5. So there is no remainder of 5 left. So 101 minus 5 will give you 96. Now, if we find out a number that divides these two numbers equally without any remainder, then that same number will divide these two numbers with a remainder of 5. Now you get it? Now let's see how we can do that. So we are actually finding out the HCF. So let's find out the HCF of 144 and 96. So here we have the numbers 5 subtracted from the given numbers. We have 144 and 96. Let's find the HCF of 144 and 96. So how do we do that? We write the given numbers in a grid. So 144 and 96. The smallest common prime factor for these two numbers is 2. So we have 2 here and 144 divided by 2 gives you 72 and 96 divided by 2 gives you 48. Now we can divide these two quotients again with 2 as the common smallest possible prime factor. So 72 divided by 2 gives you 36 and 48 divided by 2 gives you 24. Again these two numbers can be divided using 2 itself. So 36 divided by 2 gives you 18 and 24 by 2 gives you 12. Again these quotients can be divided. So 18 by 2 gives you 9, 12 by 2 gives you 6. Now here can 2 divide both these numbers? No, 2 can divide 6 but not 9. But this 9 and 6 are multiples of 3. So we can use 3 to divide both these numbers. So 9 divided by 3 gives you 3, 6 divided by 3 gives you 2. Now are there any more common prime numbers which we can use to divide these two quotients? No. So let's stop the division right there and we have to take the product of all the common prime factors. So what is it? It would be equal to 2 into 2 into 2 into 2 into 3. So what is the product? The product will be equal to 48. So that is the HCF of these two numbers 144 and 96. So that is the greatest number that divides these two numbers completely without any remainder, and the numbers 149 and 101 leaving a remainder of 5. So I hope this is clear to you. Now as an activity for the day, you have to go through the topic word problems in page number 45 of your textbook, and then you have to do question numbers 2, 3 and 4 of exercise 3.3, and right below that you have a heading HOTS. Please go through that as well and do accordingly. So that's all for today. We will meet in the next class. Until then, bye.